All right, guys, I know some of us are having troubles with radicals, so this is the radical bell work that we did for a couple of days. Hopefully this will help you out. Remember, simplifying the radicals is a small part of it, of doing the quadratics. You can at least get to that point every time, and if you're trying to do this, I'm going to give you a lot of credit. Remember, on a STAR test, we could put in our calculator and compare it to the answers that they gave us. So if you can't do this, it's not the end of the world, but it is important. So this first one, guys, we have what we call perfect squares, numbers that will, if we take the square root, will give us whole numbers. Like the square root of 1 is 1. The square root of 16 is 4. The square root of 49 is 7. And the square root of 169 is 13. So what we're going to do is form a list of some perfect squares like these numbers so that when we see them, we'll know we've got it easy. 1 is a perfect square. Another perfect square is 4. Our next perfect square is 9. Our next perfect square would be 16, but we've already got that one written below. So these are basically the square root, of 4 and the square root of 9 equal 2 and 3. So 1, 4, 9, and 16 are perfect squares. Then we could go to the next one, which is the square root of 25 is 5. Then we have the square root of 36 equals 6. So far we have 1, 4, 9, 16, 25, 36. Those are our perfect squares. Now, next one was 49 was 7. After that, our next perfect square is 64, which is 8. Then we went to 81, which is 9. And then to 100, which is 10. The square root of 121 is 11. The square root of 144 is 12. We already had 169 is 13. The square root of 196 is 14. And the square root of 225 is 15. So these numbers that are inside the square roots are perfect squares, and you need to remember them. We had 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Now these are going to be important on the next part because these are going to help us break down and simplify radicals that are not perfect squares. So let's go to the next one. Now to simplify radicals that aren't perfect squares, we need to know what the perfect squares are, and we just wrote them up top. So what we're going to basically do is factor them, kind of like we did on sum and product, and see if any of our perfect squares will go into them evenly. So I'm going to take 12 out here. Now our first perfect square is 1, but dividing anything by 1 doesn't help. So I want to start going up my line of perfect squares. Well, after 1 is 4. Well, 4 does go into 12 3 times. So what I'm going to do is rewrite the square root of 12 as the square root of 4 times 3. I found a perfect square that worked, so I used it. Now I'm going to rewrite that a different way. The square root of 4 times 3 is the same as the square root of 4 times the square root of 3. And this is where using the perfect square helps us out, because I actually know the square root of 4 is 2, but I can't do anything with the square root of 3, so I tack it on at the end. The simplified version of the square root of 12 is 2 square roots of 3. So let's look at 20. Now again, 1 doesn't ever help us, so I need to go to 4 first. 20 is divisible by 4. It goes into it 5 times. So again, I can rewrite this as the square root of 4 times 5, which is the same as the square root of 4 times the square root of 5, which is 2 times the square root of 5, or 2 square roots of 5. So I want you to try 45 real quick. You start with 4 and work your way up. You might want to pause for that. Now I'm going to break this down. 4 doesn't go into 45, so I have to go up my perfect square list to 9. 9 does 5 times. So I'm going to break apart 45 into the square root of 9 times 5, which is the square root of 9 times the square root of 5, which is 3 square roots of 5. So if we're not using the perfect square, we can't break it down further. So make sure you find a perfect square. Let's see if we go to 50. Go ahead and try this one. Start with 4. You might want to pause the video, give yourself a chance. 4 does not go into 50. 9 does not go into 50, so I need to keep going on the list. 16 does not go into 50, but 25 does 2 times. So I rewrite this as 25 the square root of 25 times 2, which is the square of 25 times the square root of 2, which leaves us with 5 square roots of 2. So I hope this helps you out a little bit. Of course, let me know in class if you're having any trouble.